Relax and fall asleep with facts about Enceladus, Saturn's most extraordinary moon. Discovery and naming. There is a place, far out in the cold and the silence of our solar system, that most people have never thought about. A small, quiet world, drifting through the darkness more than 800 million miles from the warmth of the sun. It is not a planet. It is not a comet. It is a moon, one of many that circle the great ring giant we call Saturn. And it is, in many ways, one of the most extraordinary places ever found in the history of human exploration. Its name is Enceladus. Say that name slowly if you like. Enceladus. There is something almost musical about it, something that belongs to ancient stories and old mythologies. And there is a reason for that, which we will come to in a little while. For now, just let yourself settle. Let your body grow heavy and comfortable wherever you are. Let your breath slow down and slow down again. There is no rush here. We have all the time in the world, and we are going to spend that time drifting, gently, quietly, through the story of one of the most fascinating worlds our solar system has to offer. The universe is full of places we will never visit in our lifetimes. Places that exist only as data, as photographs taken by spacecraft billions of miles away, as numbers collected by instruments too precise for us to fully comprehend. But there is something beautiful about knowing those places are there. Something deeply comforting about lying still in the darkness and thinking about how much is out there, how much light, how much ice, how much quiet mystery, existing in the void while we sleep. Enceladus is one of those places, a world that exists quietly, beautifully, brilliantly, out in the dark, patient and vast and full of secrets. So let us begin at the beginning. Let us travel back in time, more than 200 years, to the night when a human being first set eyes on this small and extraordinary world. The year was 1789. The place was England, and the man holding the telescope was named William Herschel. William Herschel was one of the greatest astronomers of his age. He had already done remarkable things by the time that August arrived. He had discovered the planet Uranus just a few years before, becoming the first person in recorded history to add a new planet to the list of known worlds. He built his own telescopes, grinding the mirrors himself with extraordinary patience, spending long hours in the cold night air looking upward at the sky with a dedication that is difficult to fully imagine. On the night of August the 28th, 1789, Herschel turned his telescope toward Saturn. The instrument he was using was the largest telescope in the entire world at that time. Its mirror measured 1.2 meters across, nearly 4 feet wide. A massive and extraordinary piece of engineering for its era. And through that telescope, in the faint and distant glow of the ringed planet, he spotted something new. A tiny point of light, moving steadily, quietly, orbiting just beyond Saturn's great glowing rings. He had found Enceladus. He didn't know, of course, what he had truly found. He couldn't have known. From where he stood, in the observatory he had built with his own hands in England, Enceladus was nothing more than a dim, faint point of light. A dot, a single pixel in the vast and dark canvas of the night sky. He knew it was a moon. Its slow movement around Saturn made that clear enough, but what it was made of, what was happening on its surface, what lay beneath that surface, all of that was completely invisible to him. Invisible to everyone. And it would remain that way for a very long time. Enceladus became the 6th moon of Saturn to be officially discovered. Saturn, of course, is not a difficult planet to notice in the night sky. It is one of the brightest objects visible to the naked eye, that steady, warm, golden point of light that never twinkles the way stars do. But its moons are another matter entirely. The largest of them, Titan, can be spotted with a small amateur telescope if you know where to look. But Enceladus is far harder to see. It orbits close to Saturn, bathed in the overwhelming glare of the planet and the rings that surround it. Even with modern amateur equipment, it is extremely difficult to pick out. You have to know exactly what you are looking for. You have to be patient. And even then, it is barely there. A faint point of light, easily missed, easily overlooked. William Herschel, with the largest telescope in the world and a lifetime of patient sky watching behind him, saw it. And in seeing it, he added one more entry to the growing catalog of the solar system's worlds. For nearly 2 centuries after that night, Enceladus remained exactly what it had appeared to be through Herschel's telescope, a faint and unremarkable point of light. Astronomers knew it was there. They could track its orbit with increasing precision, calculate its period, note its distance from Saturn. But what it actually looked like, what it was made of, what was happening on or beneath its surface, all of that was shrouded in complete uncertainty. Think about what that means. Imagine discovering something, writing it down, giving it a name, and then spending nearly 200 years simply knowing it exists, without being able to see it clearly, without being able to understand it. That is what Enceladus was for most of human history. A name, a number, a question without an answer. The answers, when they finally came, would overturn everything anyone had assumed. But that is a story for later. For now, let us stay with the name itself, because the name has a story worth lingering over. The name was not given at the moment of discovery. William Herschel simply noted the moon, recorded its orbit, and moved on. It was not until 1847, 58 years after the original sighting, that a name was officially suggested. The man who suggested it was John Herschel, William's own son. John had grown up surrounded by telescopes and star charts and the endless conversation of an astronomer's household. He had inherited his father's passion for the night sky and developed it into a distinguished scientific career of his own. He had a gift for naming things, and when it came time to give names to the moons of Saturn, he turned to the ancient world for inspiration. His approach was elegant and fitting. Saturn, in Roman mythology, was a god, the god of time and agriculture, often identified with the Greek deity Kronos. And in the myths, Saturn was surrounded by other primordial beings. The Titans, the giants, the old powers of the world that existed before the Olympian gods rose to dominance. So John Herschel decided that the moons of Saturn should carry the names of those ancient beings, the Titans and giants of Greek and Roman legend. And one of those giants was Enceladus. In the old stories, Enceladus was one of the Gigantes, the giants born from the earth itself, ancient and powerful beyond reckoning. He was a leader among them during the Gigantomachy, the great mythological war between the giants and the Olympian gods, a conflict so enormous and so violent that it shook the very foundations of the ancient world. The giants, for all their power, lost. The gods prevailed. And Enceladus, the great and fearsome leader, was defeated by the goddess Athena herself. According to the myth, she did not simply kill him. Instead, she hurled the entire island of Sicily down upon him, burying him beneath the earth forever. And there, the legend says, he remains, buried under Sicily, beneath the shadow of Mount Etna, trapped, but not entirely still. When Enceladus stirs in his sleep, turns in the dark beneath the earth, Mount Etna trembles. The volcano erupts. The ground shakes. The smoke rising from the mountain is his breath. The earthquakes are his movements, a buried giant who has not entirely given up. There is something extraordinarily beautiful about that myth being attached to this particular moon, because as we will discover over the course of this journey, Enceladus the moon is not still either. Not at all. Beneath its frozen surface, something is moving. Something is stirring. Something is producing heat and fire and water in the deep cold of a world more than 800 million miles from the sun. The ancient storytellers gave that name to a restless giant buried beneath the earth. And by some beautiful coincidence, or perhaps something more than coincidence, that same name ended up attached to a restless moon buried in ice, drifting silently around Saturn. The giant beneath the island breathes fire. The moon beneath the ice breathes water. And both of them, in their own way, are very much alive. Let that image settle gently in your mind. The ancient myth, the buried giant, the distant moon. Let your breathing slow a little more. Let the weight of your body sink deeper into wherever you are resting. There is nothing you need to do right now. Nowhere you need to be. Enceladus has been drifting around Saturn for billions of years. It is very good at being patient. And tonight, so are we. There is one more detail about the naming of Enceladus that is worth carrying with us as we drift toward sleep. The convention that John Herschel established in 1847, naming Saturn's moons after titans and giants, became a standard that astronomers have followed ever since. And there is another naming convention that applies not to the moon itself, but to the features on its surface. The craters, the ridges, the long and dramatic fractures that cut across its southern pole. All of these surface features are named after characters and places from one of the oldest and most beloved collections of stories in human history. The Arabian Nights, the 1001 Nights, Scheherazade and her stories, Ali Baba and his 40 thieves, Sinbad the sailor, the lamp and the genie and the flying carpet. All of those names, those ancient, golden, exotic names, are scattered across the surface of a frozen moon drifting in the outer solar system. There is an Ali Baba crater on Enceladus. There are ridges and valleys carrying the names of merchants and adventurers and magical creatures from a collection of stories that has been told and retold for more than 1,000 years. It is a small detail, but a beautiful one. A world so remote that the human eye can barely find it in the sky, and yet its surface is mapped with names from our oldest stories, our most ancient dreams. As if the people who charted this moon wanted to make sure it felt, in some way, like home. As you drift now, deeper into rest, deeper into the soft and comfortable weight of the night, let those stories drift with you. The Arabian Nights and the buried giant and the English astronomer with his great telescope, all of them woven together in the name and the surface of a small, bright, extraordinary moon. Enceladus. Discovered in 1789, named in 1847, and still, after all this time, full of surprises that none of those early astronomers could have imagined. Rest now. The night is long and quiet, and there is no need to hold on to any of this. Just let it wash over you, gently, like the slow drift of ice crystals falling through cold and silent space. We are only beginning. There is so much more to come. Physical characteristics. Welcome back to the quiet. Welcome back to the slow and steady drift through the story of Enceladus. If you are settling in for the first time with this segment, allow yourself a moment to arrive. Find a comfortable position. Feel the weight of your body, the warmth of wherever you are resting. Let your breath settle into its own natural rhythm. Not forced, not controlled, simply observed. In and out, slow and easy. And when you are ready, let us think about what Enceladus actually looks like. How large it is, where it sits in the grand scale of things. Because there is something both humbling and quietly wonderful about the true physical nature of this moon. The way its smallness and its extraordinary qualities exist together, side by side, without contradiction. Enceladus is small, very small by the standards of worlds we are used to thinking about. Its diameter is approximately 504 kilometers, about 313 miles across. To put that number in terms that might feel more tangible, the entire moon of Enceladus, the whole globe of it, could fit comfortably within the borders of the state of Arizona. Or, if you are more familiar with European geography, within the borders of the United Kingdom. Drive from one end of Arizona to the other in an afternoon and you have crossed a distance longer than the full diameter of this moon. It is, by any measure, a small thing. And yet, when we compare Enceladus to our own moon, the one that has hung in our night sky for as long as human beings have looked upward, the one that pulls our tides and lights our dark fields and has been the subject of poetry and longing and wonder since the very beginning of recorded thought, Enceladus is about 1/7 the size. Imagine looking at the moon tonight, that familiar silver disk in the sky, and then imagining a world just 1/7 as wide. That is Enceladus. Smaller than a thought, really. A marble to our moon's softball. And yet this marble, this impossibly small cold world, is one of the most scientifically important places in the entire solar system. Size, as we will discover again and again over the course of this long night, tells us very little about significance. Saturn has 146 known moons. 146. That number is worth sitting with for a moment because it is extraordinary. Most of those moons are small, tiny, irregular lumps of ice and rock captured by Saturn's immense gravity over billions of years, tumbling in orbits that range from just a few thousand kilometers above the cloud tops to millions of kilometers out in the dark. Some of them have names. Most of them have only designation numbers, labels like S/2019 S1, codes in a long list of ice and shadow. Among those 146, Enceladus ranks as the 6th largest. Not the biggest, not the most dramatic in terms of sheer scale. Titan, Saturn's largest moon, is bigger than the planet Mercury. A world so large it has its own thick atmosphere, its own weather, its own rivers and lakes of liquid methane. Compared to Titan, Enceladus is a tiny neighbor, drifting in a much closer orbit, quiet and bright. But quiet and bright, as it turns out, are deeply deceiving. The mass of Enceladus, the total amount of matter it contains, is roughly 1.08 times 10 to the power of 20 kilograms. That is an enormous number in one sense, and yet it represents less than 0.02% of Earth's total mass. Enceladus is light, delicate in cosmic terms, a small, cold, bright thing drifting around a giant. Its density, the ratio of its mass to its volume, is about 1.61 grams per cubic centimeter. This number matters because it tells us what the moon is made of. Water, in its liquid form, has a density of exactly 1 gram per cubic centimeter. Rock, the ordinary silicate rock that makes up much of Earth's interior, generally sits between 2 and 3. The density of Enceladus, sitting between those values, tells us immediately that this moon is a mixture of both. Ice and rock, layered and combined. Not a simple frozen ball, but a genuinely complicated structure with a rocky core at its heart and layers of ice wrapped around it. Understanding the interior structure of Enceladus is something we will spend a great deal of time on later in this journey, because what lies inside this small world is where the most breathtaking secrets are hidden. For now, just hold that image. A world of ice wrapped around a core of rock, drifting through the outer solar system in the faint light of a distant sun. There is something almost meditative about thinking of ice and rock together. The hardness and permanence of stone, the coldness and quiet beauty of ice. Together they make something that is neither fully one thing nor the other, a blend, a compromise, a world that is in between. Like so much of what makes Enceladus remarkable, the truth of it turns out to be more layered than anything you might expect at first glance. But of all the physical characteristics of Enceladus, the one that is most immediately and dramatically visible, the one that would strike you first if you could somehow hover in space nearby and look at it, is its color, or rather, its brightness. Enceladus is the most reflective body in the entire solar system. This quality has a scientific name, albedo. It is a measure of how much of the light that strikes a surface is reflected back, as opposed to absorbed. A perfect mirror would have an albedo of 1, reflecting 100% of incoming light. A surface that absorbs everything and reflects nothing would have an albedo of 0, like a perfectly black piece of fabric. Most worlds in our solar system have albedos somewhere in between. Our moon reflects about 12% of the sunlight that falls on it, absorbing the rest, which is why its surface looks the color it does, that dusty and somewhat warm gray. Earth reflects about 30% of incoming sunlight. Venus, with its thick and highly reflective clouds of sulfuric acid, does better, about 70%. Enceladus reflects close to 100%. Nearly all of the light that falls upon its surface bounces straight back into space without being absorbed at all. It is, in practical terms, a perfect mirror. A sphere of ice so clean, so fresh, so constantly renewed that it simply returns the sun's light to the universe rather than taking any of it in. Stand on the surface of Enceladus, if you could, and we'll imagine you could, wrapped in your best spacesuit, standing on the ice, and the world around you would be dazzlingly, almost painfully white in every direction. The ground beneath your feet would reflect the sun's light back up at you. There would be no shadow, no dust, no discoloration anywhere. Just white. Pure, brilliant, almost clinical white, stretching to every horizon. It would be like standing inside a diamond. This extraordinary reflectivity exists because the surface of Enceladus is covered in fresh, clean water ice. Not old ice. Not the kind that accumulates years of cosmic dust, radiation damage, and micrometeorite impacts until it turns gray and dull. But genuinely fresh ice, newly fallen, constantly replenished by a process we will describe in detail later in this journey. The surface of Enceladus is, in a very real sense, snowing on itself. Continuously, a world that keeps its own surface perpetually new. But here is the surprising consequence of all that reflectivity. You might think that a world so good at bouncing light back into space would somehow be warmer for it, that all that brightness would suggest some sort of energy, some warmth. But the opposite is true. Because Enceladus reflects almost all of the sunlight that reaches it, it absorbs almost none of the heat that comes with it. And so its surface is extraordinarily, ferociously cold. The average surface temperature of Enceladus at its equator at noon, the warmest it ever gets, anywhere on its surface at the warmest time of day, is approximately negative 330 degrees Fahrenheit. In Celsius, that is negative 201 degrees. To put that in a frame of reference that might mean something, The coldest temperature ever recorded on the surface of Earth was about -128 degrees Fahrenheit, measured at the Vostok Station in Antarctica during the depths of the polar winter. That is the absolute extreme of cold that our planet has ever experienced at its surface. Enceladus, at its warmest, is more than 200 degrees Fahrenheit colder than that. It is a world of extraordinary, almost inconceivable cold, bright and beautiful and frozen far beyond anything we experience here. A mirror in the dark, reflecting light it cannot use, drifting in a silence so deep that no sound has ever disturbed it. And yet, and we will say this again because it bears repeating, beneath all that cold, beneath all that ice, beneath all that brilliant and deceptive whiteness, something warm is happening. Something unexpected and astonishing. Something that changes everything we thought we understood about where life might be possible in the universe. But that is not yet. That is for later, when we are deeper into the night and deeper into the story. For now, let Enceladus simply be what it appears to be on the outside. Small, cold, impossibly bright. A marble of ice drifting in the outer dark, named after a buried giant, first seen by a patient man with a great telescope, orbiting quietly around the most beautiful planet in the solar system. Let your body grow heavier. Let your breath grow slower. Let the image of that brilliant white moon drift across your mind like a slow cloud, bright and quiet and full of things it has not yet told us. You are already very relaxed. The world around you is soft and distant. The night is doing what nights do, deepening, gentling, pulling you gently down towards sleep. Enceladus is out there right now, in this very moment, turning in the dark around Saturn. It has been doing so for billions of years, patient and bright and full of secrets. And we are just beginning to know it. Orbit and rotation. Let yourself settle again into stillness. If you have been drifting in and out of sleep, that is exactly right. That is precisely what this is for. Let the words come to you softly, without pressure, without any need to hold on to them. They will do their work whether you are fully awake to receive them or not. We are going to talk now about movement, about the way Enceladus moves through space, the arc of its path around Saturn, the rhythm of its days, and the hidden forces that pull and squeeze and shape it in ways that have profound consequences for everything that makes this moon so extraordinary. Movement, of course, is everywhere in the solar system. Nothing is still. Not a single body, not a single particle. Everything orbits something. Moons orbit planets, planets orbit the sun orbits the center of the Milky Way, and the Milky Way itself is moving through the larger fabric of space. Motion is the fundamental state of things. Stillness, the kind of stillness you feel right now, lying in the dark with your eyes closed and your body at rest, is in some deep and beautiful way an illusion. You are moving too on a planet that spins on its axis, that swings around the sun, that drifts through a galaxy. You are, right now, traveling at roughly 67,000 miles per hour around the sun, and you feel nothing of it at all. That is the beautiful paradox of large-scale motion. At a certain scale, it becomes indistinguishable from perfect stillness. Enceladus knows something about that. Enceladus orbits Saturn at an average distance of 238,000 kilometers from the planet's center. That is close, very close by the standards of the outer solar system. To put it in perspective, our own moon orbits Earth at a distance of about 384,000 kilometers. Enceladus orbits Saturn at a little more than half that distance, relatively speaking. It sits well inside Saturn's vast ring system, tucked into a region of space dominated by the planet's enormous gravitational influence. And because it orbits so close to such a massive planet, it moves very quickly. The orbital velocity of Enceladus, The speed at which it travels along its path around Saturn is roughly 12.5 kilometers per second. That is about 28,000 miles per hour. Moving at that speed in the same direction as Enceladus, you would circle the entire Earth in about 35 minutes. You would travel from New York to Los Angeles in less than 3 minutes. 12.5 kilometers per second, around and around Saturn endlessly, relentlessly. And yet the orbit itself is so large that even at this extraordinary speed, it still takes about 32.5 hours, roughly 1 1/3 Earth days, for Enceladus to complete one full trip around Saturn. That is Enceladus's year, 32.5 hours. A year shorter than an Earth day and a half. It has orbited Saturn more times than there are years in all of recorded human history, more times than there are grains of sand on a modest beach. It is an orbit it has completed so many billions of times that the number loses all meaning. Round and round and round. Constant, steady, patient. Like our own moon, Enceladus is tidally locked to its host planet. This is a fundamental and common phenomenon in orbital mechanics, and it has an elegant explanation. When a moon orbits a planet, the planet's gravity does not pull equally on every part of the moon. It pulls more strongly on the side of the moon that is closer to the planet and less strongly on the side that is farther away. This difference in gravitational force, called a tidal force, creates a slight elongation in the moon's shape, a stretching. The moon becomes very slightly football-shaped rather than perfectly spherical, with one end pointing toward the planet and the other end pointing away. Over millions of years, this tidal elongation acts as a brake on the moon's rotation. If the moon is spinning faster than it orbits, the elongated ends are always being pulled by the planet's gravity, creating a frictional drag that gradually slows the rotation until it matches the orbital period exactly. Once that happens, the moon always keeps the same face pointed toward the planet, one side permanently facing the planet, the other side permanently facing away. This is the state of Enceladus. One hemisphere perpetually faces Saturn. The other hemisphere perpetually faces the empty dark of outer space. Just as our moon always shows us the same face from Earth, the familiar man in the moon, or the rabbit in the moon, or the face in the moon, depending on where in the world you grew up and what stories you were told, Enceladus always shows the same face to Saturn. The planet it orbits is always in the same position in its sky, enormous and radiant and unchanging. Imagine that for a moment. Standing on the Saturn-facing side of Enceladus, you would always see Saturn exactly overhead or close to it. That vast, ringed, golden-brown planet, never rising, never setting, just hanging there in the black sky, enormous and permanent. Day after day after day, though of course the days on Enceladus, like its years, are only 32 hours long. And on the other side of the moon, you would never see Saturn at all. Just the stars, eternal and unchanging, and the faint distant sun, much smaller than we see it from Earth, and the darkness between them. Two very different skies on two sides of the same small world. Now here is where the story of Enceladus's orbit becomes truly interesting. Because there is a complication, a gravitational complication, that has consequences far beyond the simple fact of how and where Enceladus moves through space. Enceladus does not orbit Saturn alone. Nothing in a complex planetary system like Saturn's ever does. It orbits in the company of many other moons, and among those moons, one in particular has a very special relationship with Enceladus. That moon is Dione. Dione is larger than Enceladus, considerably larger, about twice the diameter. It orbits Saturn farther out than Enceladus does, moving more slowly along a wider path. And here is the key. Enceladus and Dione are locked into what is called an orbital resonance, specifically a 2-to-1 resonance. For every single orbit that Dione completes around Saturn, Enceladus completes exactly 2. 2 orbits of Enceladus for every 1 orbit of Dione. The timing is precise and lockstep and has been maintained for millions upon millions of years. This is not a coincidence. It is the result of the way gravity works over very long timescales. Bodies in orbits that are close to simple integer ratios tend to settle into those ratios and lock there, each one pulling on the other in a repeating rhythm that reinforces the pattern rather than disrupting it. The result is that every time Enceladus completes 1 orbit, it finds itself in a very specific alignment with Dione. And every 2 orbits of Enceladus, all 3 bodies, Saturn, Enceladus, and Dione, are aligned in the same way again. This repeated gravitational pulling and tugging has a cumulative effect over time, and that effect changes everything. The most important consequence of the resonance between Enceladus and Dione is that it prevents Enceladus from settling into a perfectly circular orbit. Left to its own devices without Dion's gravitational interference, Enceladus's orbit would gradually circularize. The tidal forces from Saturn would slowly and steadily pull it into a perfect circle, and the Moon would glide around the planet in a smooth, unchanging path, always exactly the same distance from Saturn at every point in its orbit. But Dione won't allow that. Every time Enceladus swings past Dion's orbital position and the 2 moons are in alignment, Dione gives Enceladus a tiny gravitational kick. Not dramatic, not violent, but persistent and cumulative. These repeated kicks keep Enceladus's orbit slightly eccentric, slightly elliptical. Not a perfect circle, but an oval. A path that brings it a little closer to Saturn at one end and pushes it a little farther away at the other. The difference is not enormous in absolute terms. Enceladus's orbit is only very slightly elliptical. But even a slight ellipse, sustained over millions and millions of years by the steady influence of Dione, is enough to set in motion a chain of consequences that transforms this small moon from a dead, frozen rock into one of the most geologically active and potentially life-sustaining worlds in the solar system. Here is how. When Enceladus is closer to Saturn in its elliptical orbit, it feels the planet's gravity more strongly. Saturn's tidal forces squeeze it more tightly, stretching and deforming the moon's interior. Then, as Enceladus swings away to the far end of its orbit, the squeezing relaxes. The moon is pulled and stretched and released, pulled and stretched and released, over and over again with every orbit. This constant flexing and squeezing generates heat. Not dramatic, not explosive, but steady, persistent, and enormously significant. Deep in the interior of Enceladus, the tidal forces from Saturn are keeping things warm. And that warmth, as we will discover in the segments ahead, is the engine that drives everything extraordinary about this moon. The orbit creates the ellipse. The ellipse creates the tidal flexing. The flexing creates the heat. The heat creates the liquid water. And the liquid water creates the possibility of something far more extraordinary still. But let us not rush ahead. Let us stay here in the quiet rhythm of orbital motion for just a little longer. Enceladus also has an interesting relationship with Saturn's famous ring system. It orbits within the densest part of what is called the E ring, the outermost and largest of Saturn's major rings, a faint and diffuse structure that extends far beyond the brilliant, dense rings that are visible in even modest telescopes. And as we will discuss in detail later, Enceladus is not merely orbiting within the E ring, it is responsible for it. The ring exists because of Enceladus. The moon is feeding it constantly, continuously, with material ejected from its surface. But again, that story is for another part of the night. For now, simply drift with the motion of it. The steady, patient, elliptical arc of a small moon around a giant planet. Round and round, closer and farther, squeezed and released over and over for billions of years. A rhythm as old as the solar system itself and as steady as the tides. Let your own breathing find a rhythm like that. In and out, slow and steady, closer and farther, tighter and looser. You are sinking now deeper into rest. The world around you is quiet and the night is doing its slow, gentle work. Enceladus is moving through space at 12.5 kilometers per second, and it is doing so in complete and absolute silence. No sound travels through the vacuum between the stars. No one can hear the movement. It just moves, patient and precise and unknowing of itself, through the vast and quiet dark. A tiny moon, an eccentric orbit, a tidal rhythm, and the heat of a buried fire. Surface features. Come back to the quiet. Let your body settle once more into the warmth and weight of rest. If sleep has already found you, welcome. If you are still drifting in that comfortable half-world between waking and sleep, that is exactly right too. There is no wrong way to be here. We have been building, slowly and gently, toward the surface of Enceladus. We have talked about its discovery, its name, its size and brightness, its orbit and the hidden forces that shape it. Now we are going to land, not literally but in imagination, on the surface of this small, extraordinary world, and look around at what is actually there. And the first thing you would notice, standing on the surface of Enceladus, is the white. We mentioned this before, briefly, when we talked about the moon's extraordinary reflectivity. But it is worth dwelling on again, because it is so fundamental to the experience of this place. The entire surface, in every direction to every horizon, is covered in white. Clean, bright, brilliant, fresh white ice. Not the yellow-gray ice you might find in a freezer that has not been defrosted in a while. Not the blue-white of an ancient glacier. Fresh, powdery, recently fallen ice. More like the top of an undisturbed snowfield on a clear winter morning than anything else. The surface of Enceladus is, in the most literal sense, constantly snowing. We will understand why when we reach the segment about the plumes and cryovolcanism. For now, just know that the ice beneath your feet is new. It was probably not there a few decades ago. In geological terms, it arrived yesterday. But look more carefully. Look past the immediate whiteness and into the landscape itself, and you will find that Enceladus is not a uniform, featureless ball of ice. It is varied. It is dramatic. And in some places, it is genuinely unlike anything else in the solar system. One of the most immediately striking things about Enceladus, when you look at the global map of its surface, is how different its two hemispheres are from each other. The northern hemisphere is heavily cratered. Craters, as you probably know, are the scars left by meteorite and asteroid impacts, the circular depressions that accumulate on a solid surface over time as debris from space rains down on it. The more craters a surface has, the older it is. Craters tell time. A surface covered in craters has been sitting there, unmolested and unchanging, for a very long time. Long enough for the impacts to pile up over millions and billions of years. The northern hemisphere of Enceladus has many craters. The surface is old. Geologically speaking, it is relatively inactive. Not much is happening there to erase or overwrite the impact record. It is a preserved, ancient landscape, carrying in its craters the memory of billions of years of bombardment from the early solar system. Now turn around, metaphorically speaking, and look at the southern hemisphere. No craters, or very nearly none. The southern hemisphere of Enceladus is almost completely smooth, almost entirely free of the impact scars that mark most surfaces in the solar system. This is a young surface. Not young in the way that a newborn baby is young, not years or even centuries. Young in geological time, perhaps tens of millions of years old, perhaps less. In the context of a solar system that is 4.5 billion years old, tens of millions of years is very recent. It is as if the southern hemisphere has been freshly paved. Something has happened there. Something is happening there still. The surface has been remade, reshaped, renewed, and the process of renewal has been so thorough and so recent that virtually all evidence of earlier impact history has been erased. What could do that to a world? What kind of force remakes a hemisphere so completely that billions of years of impact craters simply disappear? The answer lies at the South Pole, and it is one of the most dramatic things in the solar system. At the South Pole of Enceladus, cutting across the landscape in four nearly parallel lines, are structures unlike anything else ever observed on any moon or planet. They are called the tiger stripes. The name is informal, a nickname given by the scientists who first saw them in the Cassini spacecraft's images and immediately recognized that they looked remarkably like the stripes on a tiger's coat. For long, parallel fractures, cutting across the south polar terrain in a pattern that is both orderly and dramatic. And the numbers that describe them are extraordinary. Each of the tiger stripes is approximately 130 kilometers long. That is roughly 80 miles. They run almost parallel to one another, separated by fairly regular spacing, in a pattern that is almost geometric in its precision. Each one is about 2 kilometers wide enough that you could drive a car across the bottom and still have room on either side. And they plunge to depths of about 500 meters, nearly a third of a mile deep, into the body of the moon. They are enormous. Standing at the edge of one and looking down into it, you would be looking into a fracture that makes the Grand Canyon look modest. A chasm in the ice, deep and dark and cold, cutting into the crust of this small world as if something enormous had grabbed the moon and pulled it apart. Which, in a sense, is exactly what happened. The tiger stripes are tectonic fractures, cracks in the crust formed by the same tidal forces we discussed in the previous segment. As Saturn's gravity squeezes and stretches Enceladus over and over again with every orbit, the crust experiences stress. And where the crust is weakest, in this case at the South Pole, it cracks. The cracks propagate, grow, deepen, and are held open by the continuing tidal flexing. They are, in essence, wounds in the surface of the moon, and they are wounds that never fully heal. The 4 main tiger stripes have formal names, and those names, like so many features on Enceladus, come from the Arabian Nights. They are called Alexandria Sulcus, Cairo Sulcus, Baghdad Sulcus, and Damascus Sulcus. Sulcus is the Latin word for a groove or furrow, an appropriately understated term for fractures on this scale. Alexandria, Cairo, Baghdad, Damascus, for great ancient cities, their names written in ice on a frozen moon a billion miles from Earth. There is something lovely about that, something that speaks to the breadth of human imagination and the reach of our need to make distant things feel a little more like home. But the tiger stripes are far more than dramatic landscape features. They are the source of something even more extraordinary. If you were standing at the edge of Damascus Sulcus and looking down into the fracture, you would notice after a moment that the air, if you could call it air, is not still. Something is moving upward from the depths of the fracture. Not quickly, not explosively, but steadily, continuously, like the steam rising from a warm vent on a cold morning. Material is coming up, out of the fracture, out of the moon itself, rising up through the crack in the crust and continuing upward, higher and higher, until it escapes the gravity of Enceladus altogether and disperses into space. The tiger stripes are not just fractures. They are vents. They are the exits through which Enceladus exhales. And what it is exhaling is something remarkable. But we are getting just a little ahead of ourselves. Before we talk about what comes out of the tiger stripes, let us spend a little more time on the surface itself. Because there is more to see, more to imagine, more to let drift through the mind as sleep comes closer. Beyond the tiger stripes and the smooth terrain of the South Polar region, the surface of Enceladus is far from featureless. There are extensive networks of ridges and valleys across much of the moon, the geological signatures of a long and complicated crustal history. The ice crust of Enceladus has been pulled, compressed, folded, fractured, and reformed many times over the course of the moon's existence. The ridges and valleys are the record of that history, written in ice and preserved by the cold. In some regions, there are large blocks of ice, house-sized and larger, scattered across the surface as if someone had broken apart a great ice sheet and let the pieces tumble where they would. These blocks are thought to have formed when tectonic forces fractured the crust and the broken pieces tilted, rotated, and settled into new positions. They are the ice version of the floating ice flows you might see in Arctic seas on Earth, the same basic process driven by the same basic physics, but in a very different and much colder environment. And everywhere, all the time, there is snow. Not heavy, dramatic snowfall, not a blizzard, something much quieter and more delicate than that. A constant, gentle, barely perceptible drift of tiny ice crystals falling back to the surface from above. The surface of Enceladus is perpetually being refreshed by material that the moon's own activity sends up into space, and which then falls back down again, coating everything in a thin and steady layer of new, clean, bright ice. This is why the surface is so fresh. This is why there is no dust, no graying, no darkening from cosmic radiation. The surface of Enceladus is being continually renewed, like a field of snow that never stops falling. In some places near the tiger stripes, estimates suggest the accumulated snow, the fallback from all those centuries of gentle, constant snowfall, could be over 100 meters deep. That is more than 300 feet of soft, powdery ice, built up layer by layer over thousands of years, each new layer covering the last. Imagine walking through that, your feet sinking with every step, the ice giving way silently beneath you, the weight of your body creating impressions that would remain undisturbed for years before the next snowfall filled them in. The silence would be absolute. No wind, no water, no creatures, no sound of any kind. Just you and the ice and the enormous presence of Saturn in the sky above, watching. That is the surface of Enceladus. Cold beyond imagining, white beyond imagining, silent beyond imagining. And beneath it, as we will discover, something that is none of those things. Let yourself sink now, as if into that deep, soft snow. Let the weight of the night carry you down. Your body is warm. Your mind is drifting. The surface of Enceladus is cold and white and still, and beneath you, if you can feel it, is the faint and steady warmth of something alive. Rest. The tiger stripes are exhaling into the dark, and we will follow that breath into space in the segment that comes next. But for now, rest. Plumes and cryovolcanism. Let yourself come gently back to awareness, or let this wash over you as you drift. Either way, you are in exactly the right place. We left off at the surface of Enceladus, standing in the silence, in the extraordinary cold, watching something rising from the depths of the tiger stripes, something emerging from the cracks in the ice and climbing upward into space. Now let us follow it. Let us understand what it is and where it comes from and what it tells us about the astonishing nature of this small world. What rises from the tiger stripes on Enceladus is called a plume. Not a plume of fire or smoke, as you might see from a volcano on Earth. Something much colder than that, much quieter in its way. A plume of water vapor and ice crystals, erupting continuously from the south pole of this frozen moon, shooting out into the vacuum of space at remarkable speed. This phenomenon has a name: cryovolcanism. Cold volcanism. It is volcanism in the sense that material is being forced out of the interior of a planetary body by internal pressure and heat. But instead of the molten rock and sulfur dioxide that come out of Earth's volcanoes, what comes out of Enceladus is cold, or at least cold relative to what we are used to thinking of as volcanic activity. Cold by the standards of Earth's geology. By the standards of the outer solar system, however, what is happening inside Enceladus is genuinely warm. And the distinction matters more than you might expect. The plumes of Enceladus were not always known to us. For many years, for most of the history of human knowledge of this moon, no one had any idea they were there. Enceladus was just a bright, smooth moon, remarkable for its reflectivity but not obviously for anything else. The Voyager spacecraft gave us the first hints. Voyager 1, passing through the Saturnian system in 1980, observed something unusual about the E-ring, that faint, diffuse outermost ring of Saturn that extends far beyond the main ring system. The ring was puzzlingly fresh, puzzlingly bright, and Enceladus was orbiting right in the middle of it. Something seemed to be maintaining the ring, feeding it with new material to replace what was constantly being lost. But what that something was remained unclear. Voyager 2 flew closer to Enceladus in 1981, close enough to capture the first detailed photographs of the surface. Those images revealed the extraordinarily smooth southern terrain that we now know is a consequence of the moon's ongoing geological activity. But the plumes themselves, the actual jets of material being ejected into space, were too faint, too diffuse, too unexpected for the Voyager instruments to definitively detect. They were there, but nobody knew to look for them. The answer had to wait for Cassini. The Cassini spacecraft arrived in Saturn orbit in 2004, and in 2005 it made one of the most dramatic and unexpected discoveries in the history of planetary science. Flying past Enceladus in the southern hemisphere, Cassini's instruments detected something that should not have been there: a cloud of water vapor above the south pole of the moon. And then, looking with its cameras in the right direction, imaging the backlit southern limb of the moon with the sun behind it, it saw them. The plumes. Dramatic, unmistakable, awe-inspiring. Jets of material shooting up from the south pole of Enceladus and rising hundreds of kilometers into space before dispersing into the thin fog of the E-ring. They were there. They had always been there. And now, finally, we could see them. Let us think about the scale of what these plumes represent. There are more than 100 individual geysers that have been mapped and identified on Enceladus. More than 100 separate vents, most of them associated with the tiger stripes, each one shooting a continuous jet of material into space. They are not intermittent, not occasional. They are always on, always erupting, always sending material up and out and away into the vacuum above the South Pole. The speed at which the plume material is ejected is approximately 400 meters per second. That is about 900 miles per hour, faster than the speed of sound in air at sea level. A supersonic ejection of water vapor and ice crystals, shooting upward from the surface of a moon the size of Arizona. The mass of material being ejected every second is roughly 200 kilograms, about 440 pounds of material every single second being thrown into space. Every minute, that adds up to 12,000 kilograms. Every hour, 720,000 kilograms. Every day, more than 17 million kilograms of material continuously streaming away from this small moon and into the space around Saturn. It is an enormous output for such a small world. And it is not slowing down, or at least, it has not slowed down over the period that we have been able to observe it, which spans more than a decade of Cassini observations. The material that does not escape Enceladus's gravity entirely, the heavier, slower-moving particles that rise and then fall back, becomes that constant gentle snowfall we described when we were standing on the surface. The material that moves fast enough to escape gravity becomes part of Saturn's E-ring, drifting away from Enceladus and spreading out through space, constantly refreshing that faint and delicate ring with new material. Without Enceladus's ongoing eruptions, the E-ring would dissipate. In geological time, perhaps a few 100,000 to 1,000,000 years, the ring would thin and fade and eventually disappear. The fact that it is still there, still bright, still fresh, is the signature of Enceladus's ongoing and ceaseless activity. Enceladus is responsible for one of Saturn's rings, a small moon actively building one of the features of the largest, most beautiful ring system in the solar system. There is another detail about the plumes of Enceladus that is worth understanding, because it reveals something elegant about the relationship between the moon and the gravitational forces that act upon it. The plumes do not remain constant in their intensity. They vary, they pulse. They increase and decrease in brightness and output depending on where Enceladus is in its elliptical orbit. Remember the orbit we talked about, the slightly oval path that Enceladus traces around Saturn, maintained by the gravitational resonance with Dione. At one end of that oval, Enceladus is slightly closer to Saturn. At the other end, it is slightly farther away. When Enceladus is at the far end of its orbit, the point where Saturn's gravity is at its weakest pull, something interesting happens to the tiger stripes. The tidal forces that are constantly squeezing and stretching the moon are at their minimum. And this reduction in tidal squeezing means that the tiger stripes, instead of being held partially closed by compression, are pulled open a little wider. Wider cracks mean easier escape routes for the material below. The plumes brighten, the output increases, the geysers become more vigorous. Then, as Enceladus swings back towards Saturn and the tidal forces increase again, The tiger stripes are compressed slightly, the openings narrow, and the plume output decreases. The plumes breathe. They inhale and exhale with the rhythm of the orbit itself. The heartbeat of Enceladus is the heartbeat of its relationship with Saturn. The push and pull of gravity transformed into the rhythm of eruption and rest. It is one of the most beautiful examples of cause and effect in the solar system. The gravity of a distant planet, transmitted through orbital mechanics, through tidal forces, through the flexing and cracking of an icy crust, all of it culminating in the visible, measurable brightening and dimming of a plume of water vapor on a small moon a billion miles from Earth. A universe that is this connected, this intricate, this elegantly interrelated. It is the kind of thing that makes the mind go quiet for a moment, not from confusion but from simple wonder. Let your mind go quiet now. What is in the plumes? For something so dramatic, jets of material shooting into space at 900 miles per hour, the answer is, in one sense, surprisingly simple. The plumes are made almost entirely of water vapor. About 98% of the material in the plumes, by composition, is water. Not liquid water. The pressure is far too low for liquid water to exist at the surface of Enceladus. Water vapor in the form of gas and tiny ice crystals, frozen from that vapor as it expands and cools in the near vacuum above the surface. But that 2% that is not water is extraordinarily interesting. Mixed into the water vapor are trace amounts of other gases: methane, carbon dioxide, ammonia, hydrogen. Simple organic molecules, the chemical building blocks from which more complex chemistry can emerge. Hydrogen gas was detected in the plumes by Cassini in 2017, a discovery that caused considerable excitement in the scientific community because of what it implies about the processes happening deep inside the moon. And mixed into the solid ice particles of the plumes, tiny grains of frozen material, some as small as a few nanometers across, are more complex compounds. Silica, salt, organic molecules that are heavier and more complicated than the simple gases in the vapor phase. Some of the organic molecules detected in the plumes of Enceladus are genuinely large and complex macromolecules, carbon-rich structures of a type that, on Earth, are associated with biological chemistry. The plumes of Enceladus are, in a very real sense, a gift. A free sample of the interior of the moon, delivered directly to space in a form that passing spacecraft can fly through and analyze without needing to land, drill, or dig. The ocean beneath the ice of Enceladus is sending us messages, continuously, through those jets of water and ice and chemistry that stream out from the tiger stripes every second of every day. And the messages are remarkable. But the full meaning of those messages, what they tell us about the ocean below, about the chemistry happening there, and about the possibility of something even more extraordinary, that is a story that deserves its own segment, its own space, its own time. For now, let the image of the plumes simply be beautiful in your mind. Thin jets of water vapor and ice, rising from the cracks in a frozen moon, reaching up into the black and star-filled sky above Saturn's south pole, catching the light of a distant sun and scattering it into a shimmer of silver crystals before dispersing into the vast and patient E-ring. Beautiful, continuous, unending. The moon breathes, and in its breathing, it is slowly telling us something very important. Let your own breathing slow now. Let it match that rhythm, steady, patient, continuous. In and out, up and down. The plume rises and the snow falls and the ring drifts and everything is connected to everything else in ways that take a long time to fully see. You are getting very sleepy, very comfortable, very still. The plumes are still rising out in the dark, and we will follow their chemistry down through the ice into the ocean below in the segment that comes next. But that is for later. For now, simply rest. The subsurface ocean. You are resting now deeply and comfortably. Let the quiet carry you forward. There is no effort required here, just the gentle drift of words and the slow, pleasant weight of sleep. We have been descending, slowly and gently, toward the most extraordinary thing about Enceladus. We started at the surface, the brilliant white ice, the ancient craters of the northern hemisphere, the dramatic fractures of the tiger stripes. We watched the plumes rising from those fractures, carrying water and chemistry up into space. And now, following the logic of those plumes, we are going to go down through the ice, down past the surface features and into the interior of the moon, where something exists that changes everything we thought we understood about where liquid water and possibly life can exist in the universe. Beneath the icy surface of Enceladus, there is an ocean, not a small pond, not a subglacial lake. An ocean, a global body of liquid water, wrapping all the way around the rocky core of the moon, extending under the ice shell from pole to pole and all the way around the equator. A continuous, connected, global ocean of liquid water, hidden beneath miles of ice. In a world where the surface temperature is -200 degrees Celsius, more than 1 billion kilometers from the sun. An ocean that should not exist. An ocean that has no business being there by any straightforward application of what we thought we knew about where liquid water can survive. And yet there it is. The evidence is unambiguous. The ocean of Enceladus is one of the most well-established facts in modern planetary science. Let us understand how we know it is there. The discovery of the subsurface ocean of Enceladus was not an instant revelation. It came in stages, each one adding more certainty, each one expanding our understanding of just how extensive and significant this hidden body of water truly is. The first strong evidence came from the plumes themselves. When Cassini analyzed the material in the plumes in 2005 and the years that followed, it found salt sodium chloride, the same salt that makes Earth's oceans salty. Finding salt in the plume material was significant because it indicated that the water in the plumes had not simply condensed from some other source, but had spent time in contact with rock, specifically with the rocky core of the moon. Rock dissolves into water over time, releasing minerals and salts. The salt in the plumes was a signature of rock-water interaction deep inside the moon. The second line of evidence came from the silica nanoparticles detected in the E-ring material. Silicon dioxide silica forms nanoparticles of specific sizes under specific conditions. The particles found in the Enceladus plume material could only have formed if water at the base of the ocean had reached temperatures above 90 degrees Celsius, above the boiling point of water at sea level on Earth, before being ejected. This meant there were regions of very hot water somewhere inside Enceladus. Hot water deep underground in contact with rock, dissolving silica and then ejecting it as nanoparticles. The third and most comprehensive evidence came from Cassini's gravity measurements and its careful tracking of the precise motion of Enceladus over many years. When Cassini mapped Enceladus's gravitational field in detail, scientists found an anomaly beneath the South Pole, a region of lower than expected density beneath the southern crust, consistent with a large body of liquid water. This was the first direct detection of the ocean's presence below the tiger stripes. And then came the wobble. In planetary science, There is a phenomenon called libration, a slight rocking or wobbling in a tidally locked moon's rotation, caused by the same tidal forces that keep it locked in the first place. All tidally locked moons have some degree of libration, but the amount depends critically on what the moon is made of inside. A moon that is solid all the way through, a uniform, rigid sphere of ice and rock, responds to tidal forces differently than one that has a liquid layer somewhere inside it. A solid moon is stiffer. It resists the tidal tugging more effectively. Its libration is smaller. A moon with a global liquid ocean decoupled from its outer shell is different. The outer shell can rotate very slightly independently of the inner core, and the ocean between them allows that slight independent motion. The result is a larger, more easily detectable wobble. When Cassini measured the libration of Enceladus, the tiny, precise rocking of the moon's rotation as it orbited Saturn, the measurement was unambiguous. The wobble was too large to be explained by a solid moon. It was, however, exactly consistent with a moon that has a global subsurface ocean completely decoupling its outer ice shell from its inner rocky core. This was the confirmation that made the ocean not just likely, not just probable, but essentially certain. The global ocean of Enceladus was confirmed by its own wobble, by the subtle, patient, measurable consequence of liquid water existing beneath ice. It is a beautiful piece of scientific detection. No direct observation, no drilling, no landing, just the precise measurement of a tiny wobble in the rotation of a distant moon and the knowledge of what that wobble means. So what do we know about the ocean itself? What is it like down there, beneath the ice? The ice shell that covers the ocean is estimated to be between 20 and 25 kilometers thick on average, roughly 12 to 15 miles of solid ice. That is comparable to the deepest parts of Earth's oceans in terms of depth, but in the opposite direction, pressing down from above rather than up from below. At the South Pole, directly above the tiger stripes, the ice is much thinner, perhaps only 2 to 5 kilometers thick, less than 2 to 3 miles. This is where the heat from the ocean and the vents below comes closest to the surface, thinning the ice from beneath like a hand pressed up against the bottom of a frozen lake. Below the ice shell lies the ocean. Its depth is estimated at somewhere between 26 and 31 kilometers, about 16 to 19 miles deep. By comparison, the deepest point in Earth's oceans, the Challenger Deep in the Mariana Trench, is about 11 kilometers deep. The ocean of Enceladus is deeper than the deepest point of Earth's oceans. A small moon, hidden in ice, with an ocean deeper than anything we have found on our own planet. At the very bottom of the ocean, the water is in direct contact with the rocky core. This is an important detail, a crucial detail, in fact. The ocean of Enceladus is not trapped between ice above and ice below. It rests directly on rock, and rock in contact with water under heat and pressure is where chemistry happens, where minerals dissolve and react and create new compounds, where, on Earth, the most productive ecosystems in the deep ocean are found. The ocean is salty, with a salinity broadly similar to Earth's own oceans. It is not pure water. It is rich with dissolved minerals and compounds, the product of billions of years of water dissolving the rocky core beneath it. And it is alkaline. The pH of the ocean of Enceladus is estimated to be around 11 or 12, strongly basic, similar to the chemistry of household ammonia or the soda lakes found in certain volcanic regions on Earth. On our planet, even very alkaline environments can host life. Organisms have been found thriving in lakes with similar pH values. The alkalinity of Enceladus's ocean is unusual, but it is not a barrier. At the bottom of Enceladus's ocean, where the water meets the rock, there is evidence of something even more extraordinary than the ocean itself. There are hydrothermal vents. On Earth, hydrothermal vents are places on the seafloor where seawater percolates down through cracks in the rock, is heated by magma below, and then rises back up through the seafloor, carrying with it dissolved minerals and chemicals from deep in the crust. These vents create plumes of hot, mineral-rich water rising into the cold, deep ocean. Structures sometimes called black smokers, for the dark, billowing clouds of chemical-laden water they produce. Around hydrothermal vents on Earth, some of the most abundant and diverse ecosystems in the deep ocean exist. In a place where no sunlight reaches, where the pressure would crush an unprotected human being, where the temperature of the vent water itself can exceed 300 degrees Celsius, life flourishes. Tube worms, shrimp, crabs, bacteria, archaea, entire food webs built not on sunlight and photosynthesis but on the chemical energy released by the interaction of hot water with rock. The evidence for hydrothermal vents on Enceladus comes primarily from those silica nanoparticles and from the molecular hydrogen detected in the plumes. The silica nanoparticles require very hot water in contact with rock at the seafloor. The hydrogen, molecular hydrogen, H2, is produced when hot water reacts with certain minerals in a process called serpentinization. On Earth, serpentinization is one of the key chemical reactions associated with hydrothermal systems. The hydrogen escapes the seafloor, rises through the ocean, makes its way up through the ice in the plume system, and is ultimately detected by Cassini flying through the plume above the south pole of Enceladus. That hydrogen traveled from the floor of a hidden ocean, through miles of water and miles of ice, and into space, where a spacecraft built by human hands was waiting to catch it. Think about that journey. Think about the distance that molecule of hydrogen traveled, from a warm, rocky seafloor in the dark of a buried ocean, all the way out into space, and what it tells us about where it came from and what is happening there. The pressure at the bottom of Enceladus's ocean, it is worth noting, is roughly equivalent to the pressure about 1 mile below the surface of Earth's oceans. Not the crushing extremes of the deepest ocean trenches, but significant pressure nonetheless. A pressure well within the range in which life on Earth thrives. An ocean, a rocky bottom, hydrothermal vents, chemical energy, the right pressure and salinity. Every box is being checked. Let that thought drift through your mind as you sink deeper into rest. An ocean, hidden beneath ice, on a small and brilliant moon 1 billion miles from the sun, warm at the bottom where the vents breathe, cold at the top where the ice holds the world in, and in between miles and miles of dark, salty, ancient water. An ocean that has been there, perhaps, for billions of years. An ocean that may not be empty. Rest now. That possibility, the most extraordinary possibility in all of modern science, is waiting for us in the segment ahead. Sleep if sleep comes. The ocean of Enceladus is patient and deep and dark, and it has been waiting a very long time to be known. Astrobiology and chemistry, come gently back to the surface of awareness, or let this drift over you like a warm current. You are already deeply rested. Whatever depth of sleep you are in, these words will find you there, softly, without urgency. We have arrived at what many scientists consider the most important question in all of modern planetary science. A question that has occupied the minds of researchers for decades, that has driven missions to the outer solar system, that has changed the way we think about where life might exist in the universe. The question is this: is Enceladus alive? Not alive in the way a forest is alive, or a coral reef, or a field of grass. Not visible life, not complex life, but alive in the fundamental molecular sense of the word, alive in the way that the first living things on Earth were alive billions of years ago, in the warm and chemically rich waters of the early oceans. Alive in the way that organisms living around hydrothermal vents on the deep seafloor are alive, surviving not on sunlight but on chemistry, building their bodies from the minerals and gases that flow from the Earth itself. Is there, in the dark and salty ocean beneath the ice of a moon 1 billion miles from the sun, something that breathes, something that grows, something that reproduces, something that is, by any definition we know how to apply, alive? We do not know, not yet, but we know enough to say with increasing confidence that it is possible, that the ingredients are there, that the conditions are right, that if life were to arise in such a place, it would have everything it needs. And that, in itself, is one of the most remarkable things that has ever been discovered. Let us think about what life requires. Not complex life, not mammals or birds or flowering plants. The most basic, fundamental form of life. The kind of life that represents the minimal requirements, the lowest possible threshold. Life, as we understand it, needs 3 things. 3 essential ingredients, without which no form of life known to science can exist or arise. The first is liquid water, a solvent, a medium in which chemistry can happen, in which molecules can dissolve and interact and react with one another. Water is the universal solvent of life on Earth, and there is strong reason to think that water-based life is likely to be the most common form of life in the universe, if life exists elsewhere. The second is an energy source. Life is not passive. It is a process, a continuously maintained state of chemical organization that requires constant energy input to sustain itself. On the surface of Earth, most of that energy comes ultimately from the sun, captured by photosynthesis. But in the deep ocean, far from any sunlight, life uses chemical energy instead. The energy released by chemical reactions between hot mineral-rich water and the cold surrounding ocean. This is called chemosynthesis. The third is chemistry, specifically the right kinds of atoms and molecules. Life, at its most basic, is built from a small set of elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. The acronym scientists use is CHNOPS. These 6 elements, in the right combinations and proportions, are the raw materials from which all living things known to science are constructed. Liquid water, an energy source, the CHNOPS elements. These are what are sometimes called the prerequisites for life, and Enceladus has all 3 of them. We have already talked about the liquid water, the global subsurface ocean, deep and salty and ancient. We have already talked about the energy source, the hydrothermal vents on the seafloor, heated by the tidal energy pumped into the moon by its orbital relationship with Saturn and Dione, producing molecular hydrogen through the serpentinization reaction. Now let us talk about the chemistry. The plumes of Enceladus, as they rise from the tiger stripes and shoot into space, carry chemical information from the hidden ocean. And when Cassini flew through those plumes and analyzed their composition in detail, what it found was a chemical inventory that grows more interesting with every analysis. Carbon is there in abundance in various forms. Simple organic molecules like methanol, ethane, and ethylene have been detected. These are small, simple carbon-containing compounds, not biology, not life, but the kind of raw chemical material from which more complex compounds can potentially form. And more complex compounds have also been found. Large, carbon-rich organic molecules, macromolecules, have been detected in the ice grains of the plume. These are not simple 2 or 3 atom molecules. These are larger, more complicated structures, the kind that on Earth are associated with the chemistry of life and its precursors. Hydrogen is there, as we discussed, produced by the hydrothermal vents. On Earth, certain microorganisms, archaea primarily, use molecular hydrogen as their energy source, combining it with carbon dioxide in a reaction called methanogenesis that produces methane and water. These organisms do not need sunlight. They live in the dark, in the deep crust and the deep ocean, sustained entirely by the chemical energy of the H2CO2 reaction. The methane in the plumes of Enceladus is, itself, something of a mystery. It is present in quantities that are higher than simple geochemical processes would readily explain. When scientists modeled the expected methane output from purely geological processes on Enceladus, they found that the observed levels were difficult to account for without invoking additional methane-producing mechanisms. One such mechanism, of course, would be biological methanogenic microorganisms producing methane as a byproduct of their metabolism. This does not prove biology, but it raises the question. It makes the question harder to dismiss. In 2023, a discovery was announced that raised the astrobiological significance of Enceladus to a new level. Phosphorus was detected in the ice grains of the E-ring, material that came directly from the plumes of Enceladus. Phosphorus, the P in schnapps, one of the 6 essential elements for life as we know it, an element that plays critical roles in the structure and function of DNA, RNA, and cell membranes, in the very molecules that carry genetic information and form the boundaries of every living cell. Without phosphorus, life as we know it cannot exist. For years, phosphorus had been conspicuously absent from the detected chemistry of Enceladus. It was there in the theoretical models, it should be there, given the composition of the rocky core, but direct detection had proven elusive. And then, with careful analysis of Cassini data, it was found. In the ice grains, in the plume material, in the ocean chemistry of Enceladus. The concentrations are remarkable. The concentration of phosphorus in Enceladus's ocean may be 100 times higher than in Earth's oceans. 100 times. Not a trace amount. An abundance. Phosphorus in quantities that would, on Earth, be associated with highly productive biological environments. Enceladus is the only ocean world beyond Earth where phosphorus has been directly detected. Europa, Jupiter's famous ice-covered moon with its own subsurface ocean, has not yet yielded direct evidence of phosphorus. Titan, with its methane lakes and complex organic chemistry, has not had phosphorus directly confirmed in its subsurface water. Enceladus is alone in this, for now, the one world beyond Earth where we have actually found this critical element in a liquid water environment. And with the detection of phosphorus, the chemical inventory of Enceladus was essentially complete. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur compounds in the form of hydrogen sulfide and other molecules. Schnapps, all 6 essential elements. all present in the ocean that is being sampled by the plumes that stream from the tiger stripes every second of every day. The ingredients are there, all of them, in a liquid water environment, with an energy source, on a world that has been geologically active for billions of years. What does that mean? It does not mean that life exists on Enceladus. Let us be clear and careful about that. Science requires evidence, and we do not yet have direct evidence of living organisms in the Enceladus ocean. We have chemistry, we have conditions, we have ingredients. We do not yet have life, but we are in a position that is, in the history of astrobiology, genuinely new and genuinely exciting. We have a world, not hypothetical, not a model, but an actual, confirmed, well-characterized world that satisfies every known prerequisite for life to arise and persist. And we can sample that world from space without landing, without drilling, without any action more complex than flying a spacecraft through the plume and analyzing what it catches. The implications for the search for life in the universe are profound. Before the discovery of Enceladus's subsurface ocean and its rich chemistry, the canonical view of the habitable zone was the traditional one, the narrow band of distance from a star within which a planet can maintain liquid water on its surface. Too close and you get a Venus. Too far and you get a frozen Mars. The Goldilocks zone, as it is sometimes called. Enceladus obliterates that concept. Here is a world so far from the sun that sunlight is barely a whisper, a world where the surface temperature would kill any known organism in seconds, and yet, deep inside, it is warm and wet and chemically rich in ways that are, by our best understanding, exactly what life needs. The energy for that warmth does not come from the sun at all. It comes from tidal forces, from the gravitational relationship between Enceladus and Saturn and Dione. And tidal forces exist throughout the universe. Wherever there are moons orbiting planets, there are tidal forces. Wherever there are gas giants with large satellite systems, and we now know that such systems are common throughout the galaxy, there are potential Enceladuses. Small moons warmed from within, harboring liquid water in the dark. The universe may be full of them. If life can arise in such conditions, if the chemistry of Enceladus's ocean is capable of crossing the threshold from complex chemistry to biology, then the implications for how common life is in the universe are extraordinary. Life would not be confined to the narrow habitable zones close to stars. It would be a process that can happen anywhere that liquid water, energy, and the right chemistry coincide. And those conditions may be far more common than anyone imagined before Enceladus was properly understood. Let that thought be the one you carry down into sleep. A universe full of small, bright, ice-covered moons, each one a world in itself, each one potentially harboring in its dark and quiet interior an ocean where the chemistry of life is being conducted without a single witness. The universe is patient. It has had billions of years to work with, and it has filled those years with an extraordinary richness of conditions and chemistry that we are only now beginning to properly appreciate. And in the quiet, warm dark of an ocean beneath the ice of a small moon around a ringed planet in the outer solar system, something may be stirring that is not so different from the very first life that stirred in the warm, chemical-rich waters of the early Earth. Sleep now. Let the thought be a gentle one, not an anxious one. The universe is very large and very old and very full of possibility. That is not a frightening thing. It is a beautiful thing. Rest and let the chemistry of Enceladus drift through your dreams. Mission history. Drift back into the gentle current of awareness. or stay where you are in sleep. These words will find you either way, softly, without urgency. We have spent several long and beautiful segments exploring what Enceladus is. Its nature, its surface, its hidden ocean, its chemistry. Now let us spend some time with how we came to know all of this. Because the story of our knowledge of Enceladus is, at the same time, the story of human ingenuity and dedication, the story of spacecraft built with extraordinary care and sent across the solar system on journeys of years to teach us things we could not have known otherwise. It is a story of discovery in the truest sense of the word. Not the dramatic discovery of a single triumphant moment, but the slow, patient, cumulative discovery that characterizes the best of science. Each mission building on the last, each dataset refining the picture, each new finding raising new questions that the next generation of missions must answer. And the machines that carry those missions, the spacecraft that travel for years across the void to reach their targets, are remarkable things in themselves. Objects of extraordinary complexity and fragility, built with such precision that they can function in the extreme cold of deep space for decades, faithfully sending their data home across 1 billion miles of empty space. Let us talk about those machines and what they found. The first visitors to the Saturn system, the first human-built objects ever to pass through that distant realm of rings and moons, were the Voyager spacecraft. 2 of them, launched in 1977, sent on slightly different trajectories through the solar system on what were initially designed as 4-year missions to Jupiter and Saturn. Voyager 1 flew through the Saturn system in November of 1980. It came within 200 and 2,000 kilometers of Enceladus, a significant distance, far enough that the moon remained relatively small in its cameras, but close enough to confirm its extraordinary brightness and to note something interesting about the E-ring that surrounds it. The E-ring, as Voyager 1's instruments showed, was unusually bright and fresh-looking for an outer ring. Saturn's main rings, the brilliant, dense, banded structures that make Saturn instantly recognizable, are made of ice and rock ranging from the size of snowflakes to the size of houses, and they are relatively stable structures. The E-ring is different, fainter, more diffuse, and apparently more recently refreshed. Voyager 1 noted the connection between Enceladus and the E-ring, the fact that the moon orbits right in the middle of the ring, but could not explain the relationship. It simply recorded it and moved on. Voyager 2 flew much closer. In August of 1981, it approached Enceladus to within 87,000 kilometers, less than half the distance of Voyager 1's approach. Close enough to take the first genuinely detailed photographs of the surface. And those photographs were immediately striking. The southern hemisphere of Enceladus, as Voyager 2's cameras revealed, was bizarrely smooth. Unusually smooth. Smooth in a way that suggested recent and dramatic geological activity. A surface that had been remade recently enough to erase the craters that should have accumulated over billions of years of existence in the solar system. Scientists looking at those images knew they were seeing something unusual, something that required explanation. But Voyager 2 had only a brief window as it swept through the Saturn system. Could look, record, and move on. Could not linger. Could not return. The Voyager spacecraft eventually left the solar system entirely. Voyager 1 crossed the boundary of the heliosphere in 2012 and is now in interstellar space, the farthest human-made object from Earth. Voyager 2 followed in 2018. Both are still transmitting data, still in contact with Earth, tiny points of human ingenuity drifting through the dark between the stars. But the secrets of Enceladus would have to wait for another mission. That mission was Cassini. The Cassini-Huygens mission was a joint project of NASA, the European Space Agency, and the Italian Space Agency. It launched from Earth in October of 1997, nearly 20 years after the Voyagers, and spent 7 years traveling through space before arriving at Saturn in July of 2004. It was a large spacecraft by any measure. At launch, Cassini-Huygens had a mass of more than 5,000 kilograms, about the weight of a large SUV, though shaped nothing like one. Its main body was roughly the size of a school bus. It carried 12 scientific instruments capable of measuring gravity, magnetic fields, infrared radiation, ultraviolet radiation, visible light, radio waves, and the composition of gases and solid particles. It also carried the Huygens probe, a separate vehicle designed to detach from Cassini and descend through the atmosphere of Titan. Cassini was an extraordinary machine, and it spent 13 years, from 2004 to 2017, orbiting Saturn, studying the planet and its moons in exhaustive detail. It completed 294 orbits of Saturn. It performed more than 100 close flybys of Saturn's various moons. It transformed our understanding of virtually everything in the Saturnian system, and its relationship with Enceladus was perhaps the most scientifically dramatic of all. Cassini made 22 close flybys of Enceladus over the course of its mission. 22 dedicated encounters, each one carefully planned, each one designed to answer specific scientific questions and to gather specific types of data. The closest of these flybys, in October of 2008, brought the spacecraft to within just 25 kilometers of the surface. 25 kilometers, less than 16 miles, skimming the surface of a world in the outer solar system, flying through the plumes themselves, sampling the material being ejected from the tiger stripes at point-blank range. Nobody planned for Cassini to fly through the plumes of Enceladus. The plumes were not known to exist when Cassini was designed and built in the 1980s and 1990s. The spacecraft was not built to sample geysers. This is one of the most wonderful aspects of the Cassini-Enceladus story. The discovery of the plumes in 2005 was entirely unexpected. Cassini was simply doing what it was designed to do, making measurements and observations as it flew past Enceladus, when it detected, to the astonishment of its operators on Earth, evidence of water vapor above the south pole of the moon. The images of the plumes, taken with the sun behind the moon in a technique called forward scattering that makes faint, thin features visible, revealed the spectacular jets rising from the tiger stripes. And then the scientists realized something remarkable. The instruments on Cassini, the cosmic dust analyzer, the ion and neutral mass spectrometer, the magnetometer, were sensitive enough to analyze the plume material if the spacecraft flew through it. Not designed for that purpose, not planned for that purpose, but capable of it. This is the kind of moment that scientists dream about. A mission launched for one set of purposes suddenly finding itself perfectly positioned to investigate something entirely unexpected and potentially far more important. The flexibility, the care, and the sensitivity with which Cassini had been built allowed it to adapt to a discovery that no one had anticipated. Over the remaining years of its mission, Cassini's encounters with Enceladus became increasingly daring, lower, faster, more directly aimed at the plumes. The 25-kilometer flyby of 2008 was a landmark moment. A spacecraft, built by human beings, designed to survive the harsh environment of deep space, skimming within sight of a moon's surface and tasting the ocean of that moon directly. The data that came back from those flybys over years of careful analysis built the picture we now have of Enceladus's ocean, its chemistry, its hydrothermal vents, its potential for life. Almost everything we know about what makes Enceladus extraordinary came from Cassini. In September of 2017, Cassini's mission ended. Not through failure, not through malfunction, through a deliberate, planned, and carefully considered final act. The spacecraft was running low on fuel. After 13 years of orbital maneuvering around Saturn and its moons, the hydrazine that powered its thrusters was nearly exhausted. Without the ability to adjust its trajectory, Cassini would eventually drift uncontrolled, and there was a risk, however small, that it might ultimately impact one of Saturn's moons. This was not acceptable. Enceladus, with its potential for life, needed to be protected from contamination. Titan, with its complex organic chemistry, similarly. A crash of Cassini onto either of these worlds, even an uncontrolled crash of a dead spacecraft, could theoretically introduce Earth microbes that might survive the impact. Planetary protection protocols, designed to prevent exactly this kind of contamination, required that Cassini be disposed of safely. And so Cassini was aimed at Saturn itself. On September the 15th, 2017, after a final series of close passes between Saturn's rings that collected extraordinary new data, the spacecraft plunged into Saturn's atmosphere. Within minutes, the increasing atmospheric pressure and the heat of entry tore it apart and incinerated the pieces. Cassini was gone. The spacecraft that had taught us more about Saturn and its moons than every other mission combined, that had discovered the ocean of Enceladus and sampled its plumes and changed our understanding of where life might exist in the universe, was gone. Burned up and dispersed into the atmosphere of the planet it had studied for 13 years. It was a sad ending in some ways, but also a beautiful one. Cassini had given everything it had to give. It had done its job with extraordinary thoroughness and grace. And in the end, it became part of Saturn itself, mixed into the clouds of the great ringed planet, indistinguishable from the hydrogen and helium that make up that world's vast and swirling atmosphere. A fitting end for a spacecraft that had orbited Saturn nearly 300 times. Since Cassini's end, Enceladus has not been forgotten. It continues to be observed from a distance by telescopes and other instruments. Most remarkably, the James Webb Space Telescope, the extraordinary infrared observatory launched in December of 2021 and placed in orbit around the Sun at the second Lagrange point, has turned its instruments toward Enceladus. And what it saw was remarkable. Webb detected the water plume of Enceladus stretching not hundreds of kilometers into space, as Cassini had observed, but 9,600 kilometers, almost 6,000 miles. A plume of water vapor extending from a small moon in the outer solar system for a distance greater than the diameter of Earth. And Webb measured the current rate of water output from the plumes, approximately 300 liters, about 79 gallons, of water every second. Every second, continuously, day after day and year after year. Water flowing from Enceladus into the space around Saturn in quantities that, over geological time, would add up to astonishing totals. These observations confirm that the activity seen by Cassini was not a transient phenomenon. Enceladus is still erupting, still breathing, still sending its ocean up through the ice and into space. The question of what comes next, of how we will continue to explore this world and ultimately answer the question of whether its ocean harbors life, is one of the most important questions in planetary science today. There have been proposals for a dedicated Enceladus mission, an orbiter that would circle the moon and fly through its plumes repeatedly, gathering far more data than Cassini could. A lander that would touch down on the surface near the tiger stripes and sample the freshly fallen snow. And perhaps, eventually, something even more ambitious, a mission to penetrate the ice itself, to enter the ocean directly and look for life in the environment where, if life exists, it lives. Those missions do not yet exist. They are proposals, concepts, possibilities. But the desire to know, the human need to answer the question of whether we are alone in the universe, is strong enough and persistent enough that the answer to that question will almost certainly be pursued, in one form or another, in the decades to come. And when the answer comes, it will be one of the most significant things humanity has ever learned. Rest now. Let the history of exploration settle into your mind. The Voyagers, Cassini, Webb, like the history of an extraordinary adventure that is still ongoing, still unresolved, still full of questions that only time and patience and ingenuity will answer. Sleep if sleep is ready for you. The story continues whether we are awake to follow it or not. Enceladus is out there right now, breathing its plumes into the dark, patient and extraordinary, and full of things it has not yet told us. The universe is very old. It has been waiting a very long time to be known, and we are slowly getting there. Curiosities, connections, and what comes next. Come gently back, one last time, to the surface of wakefulness. Or stay in the soft depth of sleep and let these final words find you there. We are near the end of our journey through the story of Enceladus, and this last segment is for the details that do not fit neatly into any single category. The surprising connections, the beautiful oddities, the glimpses of the future that make the story feel not like a finished thing but like an ongoing one. Because Enceladus is not a story that is finished. Every fact we have discussed over the course of this long night is a fact that was unknown a generation ago. Some of them were unknown a decade ago. The science of this moon is young and fast-moving and full of open questions. And in the spaces between what we know and what we do not yet know, there are some of the most extraordinary possibilities that science has ever entertained. So let us spend this last, quiet segment with the curious and the wonderful. The things about Enceladus that are simply remarkable. The ways this small moon connects to the larger solar system around it. And the possibilities that lie ahead in the future of exploration and discovery. Begin by letting go of any need to stay awake for this. Let the words come and go as they will. The night is deep and comfortable, and the story will continue whether you are conscious for every word or not. Consider for a moment the relationship between Enceladus and Saturn itself. We have talked about how the plumes of Enceladus create and maintain the E-ring. Material shoots up from the tiger stripes, escapes the moon's gravity, and disperses into a diffuse ring around Saturn. That much we know. But the relationship does not stop there. A significant fraction of the water vapor ejected by Enceladus does not stay in the E-ring. It becomes ionized, stripped of electrons by the radiation environment of Saturn's magnetosphere. And in becoming ionized, it becomes part of a charged plasma that circulates around Saturn. This plasma is part of what is called Saturn's magnetospheric plasma torus, a donut-shaped region of charged particles encircling the planet at roughly the orbital distance of Enceladus. The ionized water from Enceladus interacts with Saturn's magnetic field, creating complex electrical currents that can actually be measured and mapped from orbit. There are magnetic field disturbances that trace back to the activity of Enceladus, signatures in the planet's magnetosphere that reveal the ongoing output of the small and restless moon. Enceladus, in other words, influences Saturn's magnetic environment. A moon barely 500 kilometers across is measurably affecting the magnetosphere of a planet more than 100,000 kilometers in diameter. The scale of that influence, relative to the size of the body producing it, is extraordinary. But there is more. Some of the water that Enceladus ejects into space does not stay in orbit around Saturn at all. A portion of it, a fraction of the hundreds of kilograms per second being ejected, falls inward through Saturn's ring system and eventually enters Saturn's atmosphere directly. Water from the ocean of Enceladus, raining down through the ring system and into the clouds of the gas giant planet that Enceladus orbits. A moon is raining into its host planet. The water detected in Saturn's upper atmosphere by various observations appears to originate, at least in part, from Enceladus. The small moon is delivering its ocean, molecule by molecule, to the clouds of Saturn. This is a phenomenon unlike anything observed anywhere else in the solar system. A moon actively contributing material to its planet on an ongoing basis, changing the chemistry of a world millions of times its own mass. The scale of the solar system and the unexpected ways in which its components interact and influence one another never stop being surprising. There are other curiosities about Enceladus that are worth holding in mind as you drift toward sleep. The rocky core at the center of Enceladus is not a solid, dense object like the Earth's inner core. It is porous, sponge-like, permeated with cracks and channels and spaces through which water can move, seeping down from the ocean above, being heated by the tidal energy dissipated in the rock, and rising back up again as hot, mineral-rich fluid that feeds the hydrothermal vents at the seafloor. This porous core is important because it means the volume of rock-water interaction inside Enceladus is much greater than if the core were a solid, impermeable sphere. A porous core means more surface area for chemical reactions, more pathways for water to circulate, more opportunity for the kind of geochemistry that, on Earth, is associated with the environments where the earliest life arose. The water of Enceladus's ocean is not just sitting there, cold and still, against a solid wall of rock. It is moving through the rock, trickling through channels, being heated, reacting, dissolving minerals, rising back up as hot springs. A dynamic, circulating system, a planetary water cycle on the inside of a moon. The tidal forces that drive all of this are also slightly affecting the rotation of Enceladus itself. The sloshing of water in the subsurface ocean, the way the ocean moves and redistributes its mass as the tidal forces vary over the course of each orbit, has a measurable effect on how the moon rotates. Not dramatic, not visible to the naked eye, but real and measurable. The water inside Enceladus is so massive, and its movements so significant, that it slightly changes the rate at which the whole moon spins. An ocean so massive that it changes the rotation of its world. On the surface, meanwhile, the accumulation of ice in some regions, particularly near the tiger stripes, where the snowfall from the plumes is heaviest, may reach depths of 100 meters or more in some estimates. Over 100 meters of soft, powdery, freshly fallen ice, built up over thousands of years of gentle continuous snowfall from the moon's own eruptions. The surface of Enceladus is both ancient and perpetually new. Ancient in its overall structure and the geological history embedded in the northern hemisphere's craters. New in the constant replenishment of its surface layer, the endless gentle snowfall that keeps it always bright, always fresh, always the most reflective surface in the solar system. The tiger stripes themselves may be younger than they appear in a geological sense. The current level of geological activity on Enceladus, the fractures, the plumes, the hydrothermal vents, may be a relatively recent development in the history of the Moon. Recent, of course, in geological time. When we say the tiger stripes may be only a few tens of millions of years old, we mean young by the standards of a solar system that is 4.5 billion years old. What was Enceladus like before the tiger stripes formed? Possibly much calmer, much less active, a frozen world, slowly cooling, with little to distinguish it from countless other icy moons in the outer solar system. The orbital resonance with Dione and the tidal heating it generates may have increased in intensity over time, perhaps as the moons drifted into their current orbital configuration. And as the tidal heating intensified, the interior warmed, the ocean grew, the ice cracked, and the tiger stripes formed. A world that was once quiet, now roaring, in its cold, silent, vacuum-enclosed way, with geological activity. And in the far future, we do not know. Orbital configurations change. Resonances can be disrupted. If the resonance between Enceladus and Dione were to weaken significantly over billions of years, the tidal heating would decrease. The ocean would cool. The ice above it would thicken. The plumes would diminish and eventually cease. The tiger stripes would freeze over. The E-ring would dissipate. Enceladus might eventually go quiet again, or it might not. The orbital mechanics of planetary systems are complex and not always predictable over very long timescales. What we can say is that right now, in this moment, in this particular instant of cosmic time, Enceladus is active and extraordinary and full of the conditions that make it remarkable. And we, by extraordinary fortune, exist at a moment when we have the technology to discover this and to begin to understand it. The timing is astonishing when you think about it. A few hundred years earlier and we would not have known Enceladus existed. A few thousand years earlier and the concept of other worlds was barely formed. Yet here we are at exactly the right moment in history, when we have built telescopes and spacecraft and mass spectrometers and computers to look across 1 billion miles of space and detect hydrogen gas in the plumes of a tiny moon and understand what it means. We are, perhaps, the first generation of living things in the history of this solar system to know that Enceladus exists and what it is. That is a strange and humbling thought. Let us talk finally about what comes next, about the future of our relationship with this extraordinary moon. Scientists have proposed a dedicated mission to Enceladus, something designed not as a fly-through, not as a long-distance observer, but as a world unto itself, a mission whose entire purpose is Enceladus. One such concept, studied seriously by NASA and international partners, is called the Enceladus Orbolander. As the name suggests, it would both orbit the moon and land on its surface. An orbiting phase would allow close, repeated sampling of the plumes from a stable platform, gathering far more chemical data than Cassini's swift flybys could provide, looking for larger and more complex organic molecules, searching for signatures that would be unambiguous evidence of biological processes, things like specific amino acids in specific ratios or isotopic signatures that are characteristic of metabolism. A landing phase would bring the spacecraft down onto the surface of Enceladus, near the Tiger Stripes, where the freshly fallen snow is thickest and most recently ejected from the ocean. Sampling that snow directly, analyzing it with instruments far more sophisticated than anything Cassini carried, looking for the most delicate and telling signs of biology in a cold and alien ocean. And there is another concept, even more ambitious and perhaps even more thrilling in its imagination. Engineers at NASA's Jet Propulsion Laboratory have developed and tested a robotic system called ELS, the Exobiology Extant Life Surveyor. It is, as the description suggests, a snake-like robot, a long, articulated, flexible machine designed to navigate terrain that no wheeled or legged rover could manage. Specifically, it is designed to enter the Tiger Stripe vents themselves, to slither down through the cracks in the ice of Enceladus's south pole, descending through the narrow and irregular fractures, navigating the transition from the frigid surface to the warmer subsurface environment, going deeper than any previous instrument, going toward the ocean. This is not yet possible. The technology exists in prototype form, has been tested in Earth environments that mimic some of the challenges it would face, but a mission based on ELS has not been formally planned or funded. It is a vision of the future, not an immediate plan. But it is a vision that captures something important about what Enceladus means. It is not just a world to observe from a distance. It is a world to enter, to explore from the inside, to follow its breath down into the depths where the answers may finally be waiting. And perhaps that is the most beautiful thing about Enceladus, as we come to the end of this long and quiet journey through its story. It is a world that invites us in, literally. Unlike Europa, whose ocean is sealed beneath an ice shell estimated to be many kilometers thick with no known way through it, Enceladus is venting its interior directly into space. It is sending samples of its ocean upward, continuously, in a form that spacecraft can intercept and analyze. It is, in a sense, doing half the work for us. We do not need to land and drill. We do not need to penetrate miles of ice with machinery that does not yet exist. We simply need to be in the right place at the right time with the right instruments to catch what Enceladus is already throwing into space. The ocean of Enceladus is reaching for us. Its plumes climb hundreds of kilometers above the surface and disperse into the ring around Saturn, spreading the chemistry of that hidden sea across the space around the planet. Every kilogram of ice that drifts through that ring was, in some sense, once part of the ocean. Every water molecule in the E-ring has touched the rocky bottom of Enceladus's hidden sea, has been warmed by the hydrothermal vents, has been part of whatever chemistry or biology is happening in that dark and quiet deep. The ocean is broadcasting its contents into the void, and we are learning to listen. This is where we leave Enceladus tonight. Not with conclusions, because the conclusions have not yet been reached. Not with answers, because the most important answers are still out there, waiting for the missions and the years and the patience and the ingenuity that will eventually find them. We leave it with wonder, with the quiet, comfortable, deeply human feeling of being in the presence of something vast and extraordinary and only partially known. The feeling of standing at the edge of something, not a cliff, not a precipice, but a threshold, an opening, a new country that beckons from just beyond what we can currently see. Enceladus is out there right now, in this moment, as you drift toward sleep, or as you settle deeper into the sleep that has already found you. A tiny moon, brilliant white against the darkness, orbiting a ring giant, sending its breath up into space, carrying the chemistry of a hidden ocean to whoever has the patience and the tools to receive it. Discovered by a patient man with a great telescope more than 200 years ago. Named after a giant buried beneath the earth, who was not as still as his captors hoped. Studied by machines built with extraordinary human care and sent across the solar system on journeys of years. And now known, imperfectly, partially, but known, to be one of the most extraordinary places in the entire solar system. Perhaps in the universe. Let that knowledge settle into you as gently as the snow settles onto the surface of Enceladus itself. Quietly, steadily, without urgency. You know something now that almost no human being in the long history of our species has known. You know Enceladus. You know its orbit and its surface and its plumes and its ocean and its chemistry. You know what it is made of and how it moves and why it is warm and what it might contain. That is a remarkable thing to know. And now, with that knowledge resting gently in your mind, let the night do what it came here to do. Sleep, rest, breathe slowly, the way the plumes breathe from the tiger stripes. Steady and continuous and patient and without urgency. The universe is very large and very old and very full of extraordinary things. And you, right now, are exactly where you are supposed to be. Good night.